morning, everyone. Thank you very much for inviting me along to your group. I won't be talking about seaweed. Any sort of past life that you've come across in this presentation is usually dead and preserved in rock form as a fossil. That's my disclaimer at the beginning. And what I'm going to talk about, as Stan mentioned, is pebbles. And this comes. Oh, hang on a minute. It's just not moving on. Oh, here we go. There we go. That's a nice beach. I don't know if any of you are familiar with North Yorkshire, but this is Hornsey. And when I was writing the book, I had to dash out to get a few more pebbles, basically, to supplement the collection that I have. In fact, I've got a box of pebbles under my desk right at this minute. And these are the things that I use to write the book. So who am I? Well, Stan's given you a little bit of a potted history. There I am back in the early days, back in one of my very first missions for BGS back in 1992. I did a couple of trips to Zambia, as was the case in those days. I started in '89, Stan, so I've done about 32 years in BGS, and as was the case in those days. The usual deal with an overseas trip was to go with someone more experienced. So I went with a more senior colleague, and we went to Zambia and looked at industrial minerals. And for example, what I'm holding there is a piece of chalk. Well, you may or may not know, chalk isn't made of chalk. Chalk is actually made of gypsum. If you made a piece of chalk out of chalk, it would probably be painful to listen to if you tried to write with it, because it would be very squeaky. Gypsum's a much softer mineral. And here I am, not overseas, in the bottom photo, as I am now here in the back bedroom, which seems to have become an outpost of the British Geological Survey. So most of us are still, we're doing what we call hybrid working now. Some at home, some at work. So I'm doing about 2 or 3 days a week in the office in Keyworth. It's very quiet. Keyworth is just south of Nottingham. So I live in Nottingham. You can see here's a list of minerals that I've worked on, as Stan said, mostly industrial minerals. I have been very lucky in my career to have visited lots of places on the planet. I realise that. And here I am. This was harking back to the early days of when I first started getting interested. This is how I started. And as a little kid, maybe you were the same when you were a kid, when you were a youngster. I think my mum says this was when I was about 5. And it's the rule when you're a 5-year-old that you collected pebbles, and you usually kept them in your pocket. I had no idea what they were. And you've got to have a few. If you're a little boy, if you empty out a little boy's pockets, there's going to be a pebble in there, bound to be. There was in mine anyway. And I just liked them because they were tactile, they were nice to hold. And, you know, if you're on the beach and you see something a little bit unusual, there might be a quartz vein or something in it, and you pick it up. Well, that was over 50 years ago. So I'm getting on towards 58 now. So. And if we scroll forwards to, this was at the end of about 2016. I was contacted by a Guardian journalist by the name of Paula Kokoza. Paula's one of the feature writers for the Guardian. She's actually a writer, and actually published books. And she spent the summer holidays, as you do with your kids, on the beach. And she found a little booklet in the apartment that she was staying with, which told her about the local geology and the pebbles. So much to the amusement of her husband, her and her kids spent 2 weeks collecting pebbles, and they got really hooked into it, but not really sure what they were collecting. I mean, hopefully the leaflet gave them a few clues, but it sounds like, you know, there was still plenty they collected that they weren't sure about. So she was inspired. She thought, well, there's something in this. Pebble collecting is big. Pebbles have come to the bubble to the top again. So she got in touch with me. I was working in the communications team in BGS at the time, and I took the phone call from Paula to say, have you got anyone that will be interested in helping me write an article on pebbles? And I just thought, I'm a geologist, I could do this. So I basically arranged to meet Paula in Cromer. If you're not familiar, Cromer's in North Norfolk. It's a lovely place on the coast, lots of pebbles. Basically, Paula's criteria was somewhere within striking distance from London, that she could go out with a photographer and come back in the same day. So I thought, well, that's a good plan for me. So I drew a circle around London and Nottingham and just thought, right, okay, here we go. Norfolk, East Anglia, this is an obvious place to go. And it was a cold December day. Luckily, it was dry. And we spent the day looking at pebbles. And then Paula wrote an article. If you look for it, this article is still online. if you Google "no stone unturned, my search for the pebble hunter's holy grail," you'll find the article by Paula. And in fact, I've got a pebble from that trip. You see this one? I'll tell you all about this pebble later, but that featured in the article. This is a nice one, very nice. I'll tell you what it is in a bit, but this was something we were looking for, and doesn't actually say on there. Yes, basically, pebble hunting is what geologists do on holiday, and Stan probably can attest to this. You don't retire from being a geologist. Geology is once you're a geologist forever. Sorry, Stan. It's you know this. It's more of a passion, really. I think, for me. And if I'm on holiday, I'm endearingly called the family rock stroker, because I will often go up to cliff faces or even buildings and just sort of touch the stone, the sandstone, limestone, whatever that building's made of, much to the amusement or probably embarrassment of my children when they were smaller. Try and work out what the rock is. So here we go. So since that article with Paula, I thought, well, I'm in communications. I need to do something with this. If she thinks this is a good idea, maybe I should use this as a way of communicating geoscience to a wider audience. So I started collecting pebbles in earnest. So when I say in earnest, I mean actually going with a sample bag and a GPS and recording locations and doing it properly. And now I can work out. I know what the rocks are. I know what they're made of. Usually I know what they are. Sometimes it's very difficult to work out what a stone is. And I take field lots of inquiries on email or Twitter or wherever. And it's usually a fuzzy picture of something very fine grained, which is very, very hard, surprisingly, for a geologist to work out what it is. Is it a limestone or a basalt? Sometimes, there's very fundamental distinctions between the sedimentary and igneous rocks. Sometimes very difficult to tell from a fuzzy image on someone sent you an email to you. So I've got an embarrassment of riches of pebbles. I've tried to collect a large variety as possible. And lo and behold, in 2019, I'd spoken to the editor or one of the publishers for that published book for the National Trust. And he was in touch to say, well, we're interested in commissioning a new book on pebbles. And you may not have come across a book, and I'll show you a picture of it later, called Pebbles on the Beach by Clarence Ellis, which was published in 1953. It was republished in 2018. And I think this was what inspired Pavilion. Pavilion produced all National Trust books. National Trust isn't a publisher. They put their name on them. The books are National Trust books, but Pavilion Books Group, actually, if you look inside, it's an imprint of Pavilion Books Group. And my pebble collection was perfect for this purpose. I thought, well, I can write this. And the main writing for this took place during the lockdown. So in March last year, when I packed up my office, so on the 17th of March, the main thing I was focused on, as well as grabbing my laptop and my monitor and keyboard and all those things and a few notebooks, was what pebbles am I going to take with me? What pebbles am I going to rescue from being abandoned in the office? So I brought several boxes of books home with me, of pebbles home with me to act as the basis for this book. And I spent the summer going through, whittling those down, hundreds of pebbles down to 40 pebbles. Basically, the original instruction was 100 words and an intro. So 100 words per pebble, so 40 pebbles. I must be one of the very few authors that have said to the publisher, please, can I increase the amount of writing that I need to do? So I think I did something like 150 words per pebble. It's not a lot, obviously, but it certainly, I can't be many authors that have argued they should increase the writing by 50%. If you look at the book, if you've got a copy, I should hasten to add, I'm public sector, so any of the royalties for this book go to the British Geological Survey and not me. And it's not in the National Trust bookshops yet, because they had a surplus of books waiting, queued up to go into the shops. It won't hit the shops until March. When you go into the shops, you won't see this one. You'll see this one. This is the new cover. So it's actually done quite well. They printed about 7,000 copies. Well, they've pretty much sold out of those initial copies. This is what you'll see. It's the same book. So if you've got a copy of this one, this is a collector's edition now, I've decided. This is the one that you'll see in the future. So without further ado, what is a pebble? Well, that would think would be quite a simple question for a geologist to answer. So you might be surprised by my definition. There is a technical definition for a pebble, but for me, something that makes a lot more sense for people getting involved in pebble collecting. So a pebble is something that fits neatly in the palm of your hand. It's a smooth rock. So obviously, that means the pebble will vary in size, because you might have a huge hand, or you might be, might be a 5-year-old, and your pebble is going to be a lot smaller. There is a technical definition, and it's basically a rock. A pebble is a rock between 4 and 64 millimeters. So that's a definition that various geologists will argue with, but it's in that sort of range. If you want to sort of have something more technical, and a geologist would say, well, it's obviously made of rock. So we've got lots of different types of rock, and you may or may not be aware there are 3 basic types of rock. There's sedimentary rocks, there's igneous, and metamorphic. Well, sedimentary is basically made from sediments that have been compacted. Igneous rock generally comes from things like magma, which have cooled and solidified. And metamorphic is generally rocks that have been changed. So you might take the igneous and metamorphic, the sedimentary and igneous rocks, and they're changed by burial. So there might be great pressure and temperature, which then recrystallizes the rock. So you get different types of rock. I can show you all these types of rock as we go along. Not all of the things you will find on the beach are natural. Some of them are artificial, and you will have come across this. So you'll have things like sand, glass, bricks, concrete, tarmac, all sorts of artificial things. And actually, I've included a few of those things in my book as well. And sometimes it can be quite difficult if you have a bit of concrete with a sandy sort of matrix and a few pebbles in it. You might be confusing that with maybe a pebbly sandstone, and that is very easily done, especially when you were doing your O-levels and you draw a picture of one like I did, thinking it was natural, and my teacher told me, no, it's concrete, sorry, Clive. And that is something that I always feel a bit guilty when someone sends me a picture and say, no, sorry, it's industrial slag, it's not a meteorite. That does happen unfailingly, and you see a lot of this shiny black stuff on the beach. And in certain parts of the world, up in the northeast, is a place called Seaham. Seaham is famous for sea glass. Well, sea glass is basically glass waste that was dumped in the sea, and then over the years is rounded off into pebbles on the beach, exactly the same way as natural rocks do. So where can I find pebbles? Well, you're going to shout on the beach. There are other places you will obviously find pebbles in rivers, where they've traveled down from mountains and hills. You'll find them in lakes, so that when basically they've been transported, and obviously on the beach where the river enters the sea, or maybe just from the local geology. But you also find them away from those sort of like watery environments. You'll find them on land as well. I live in the East Midlands, and there's a lot of sandstone underneath, a lot of pebbly sandstone. If you go into North Nottinghamshire, into some of the Forestry Commission places where you might go for a walk, and under your foot will be a sandy path, and there will be lots of nice round quartz pebbles in that have popped out. So they were originally formed in rivers, and they basically the sand has been what sort of rubbed away and left behind the lovely quartz pebble so you'll find these in lots of different places. How are pebbles made? Well, I think they've started off as a rock, and what's happened then by weathering and erosion, the rock is broken down into smaller pieces, which are then transported. That transportation process will then round that rock. Essentially, the two rocks, as they travel, are bashing into each other, and the more transport that occurs, the further away from where they started life, the rounder those pebbles will become, because basically they're self-abrading. And they're washed down from the rivers. And then, as I said, I generally tend to get ahead of myself with these things because I've done this talk a few times. But basically, they'll end up on the beach. And another question I've been asked is, why do some beaches are sandy and some beaches are pebbly? Generally, that's down to the local geology and the hardness of the materials, because some rocks are very hard, some are soft. and the soft stuff, like mudstone, for example, just gets washed away. And the classic example would be, for example, the chalk. Down the chalk on the south and the east coast of the UK, you get, if you go on a chalk like this one, for example, you may find chalk pebbles on the beach. Chalk is pretty soft. It won't survive on that beach very long. It will basically get destroyed. But what does survive is the flint, the black stuff that you find, the glassy black stuff that you find, which is made of silica. You find that in the chalk. So you see a lot of flint. If you go to the southeast, you'll see a lot of flint on the beach. And that's just a fraction of where it came from. If you look at the chalk cliffs, it's mostly chalk. I mean, the flint forms bands and horizons within the chalk, but all that chalk is basically gone. It's been washed out. And on a sort of, maybe on a slightly stormy day, you might see that the sea is looking pretty milky. And that is basically the chalk that has been broken right down into silt and clay-sized material, which is then washed out to sea. So it's still there. It's just too fine to survive as pebbles. And like I said, you know, some places have harder geology than others. So if you're interested in pebble collecting, and I've got a few tips here. There are rules and there are laws, and I'll come on to this part. Generally, it's fine, but in certain places it's not. But generally, it's fine if there are no, and I'll come on to the sort of the legal side of it. So one tip I would give you is that if you're a pebble, you see a lot of people sort of walking up and down along the beach with the head stooped, looking down and walking along and just scanning to see if they see anything interesting. Now, I would argue that, yes, that's great. You might spot something. But what I suggest you do is find a spot somewhere dry, or if you've got a little seat, sit yourself down and then look very carefully at the pebbles around you. And you'll find that if you remove the top layers, that sometimes the pebbles underneath may be different. If you keep going, if you go right further down, and it's a bit like, the analogy I give is a bit like a packet of cereal. If you've got currants in there, they're going to fall to the bottom of the packet. Basically, that sort of process where it slips between the cracks, essentially. So you'll sometimes find that the top layer might all be the same sort of stuff. But if you remove that big stuff, then you'll find other smaller, really interesting little pebbles underneath. It's quite, someone has said, yeah, this is a bit of sort of mindfulness technique, basically, to slow down, stop. And it does work. I did a talk for the Sigma Science Festival recently. And after the talk, an actual physical in the room talk, you know, with people, the first one I've done for a year and a half. And I thought, well, anyone game for going on the beach and having a look? So half a dozen people came with me and we sat on the beach and we did exactly that. And we found some really nice pebbles under the sort of flint, because the top layer of flint. And if you've got a camera or a smartphone, great. The good thing about smartphones these days, if you take a photo, it will often provide geographical information in the data attached to the photo. You can upload those onto websites, and you can then what we call geolocate your image. We have an app which I'll show you later called iGeology, and you can upload the images and it will use the data in the image to position the photo correctly on the map. So that's really nice. That's a good way of just recording as well. You may recognize what this is. This is a hand lens. I've got one here somewhere. Here we go. Right. Now, obviously a hand lens is a bit like a magnifying glass, but unlike a magnifying glass, you know, normally you would do this with a magnifying glass, okay? With a hand lens, if you do this, it's going to be very difficult. If you've got a hand lens, you have to take it right to your eye and then bring the rock to it. That way, I get what I call the ooh factor. Because when we have Science Week in the BGS and lots of kids come in, I get them to this and they go, ooh, look at that. You can start to see things very clearly. This has typically a magnification of ×10 or ×20. ×10 is fine. This is a nice one because it's got a light on it, which is handy for the UK because it can be quite gloomy. That's my special hand lens. So that's nice for examining your specimens. I've got some good reference books for you. Obviously, I'm going to big up my own book, but there are plenty of other books out there which go into a lot more detail if you're really interested in geology. And generally, when I go on the beach, I will have some little Ziploc bags. You know, these little Ziploc food bags. If you put all of your pebbles together in one bag, what's going to happen? It's going to continue that process of rounding in the bag. So they're going to basically they're going to rub together. And after a little while, you'll find that you just end up with a bag of very dusty pebbles. And it may have scratched and abraded what you found. So I tend to keep them separated. And I basically will then label the bag. I might actually pop in a piece of paper into the bag just so I know what it is. I found that if I write on the bag, that'll rub off. If you pop a piece of paper in the bag and usually the location and what I think it is. So that's my way. I've got lots of these little bags with pebbles in. And as a geologist, you would expect me not to forget geological hammers. You may have an impression of geologists that we're always out with our boots on and hitting things with hammers. Not usually the case. I would argue this is for advanced pebble enthusiasts only. This is my S-twing. It's just a small hammer. I don't like a huge big hammer because basically you've got to carry a heavy hammer with you. And if you take a pebble, sometimes you might be lucky to find what we call a geode with crystals inside. You might crack open a piece of limestone and find a lovely ammonite inside, or you might find nothing. That's the risk you take. You might have destroyed your lovely pebble for nothing. If you go into a place like Charmouth, you find these little nodules of limestone, and I see people on Twitter all the time just saying, look at this amazing ammonite I've just found. Well, what they haven't told you, they've probably just broken about 50 samples to get to that one lovely one. At least 50, I reckon, because I've never found one like that. I'd love to find one. I'll be there. In fact, I'll be in Charmouth. Let's see, where are we? On Monday. And I stress safety because number of times I've hit my hand with a hammer, usually about there on my thumb, thank you, and eyeglasses. You get a bit of flyaway rock when you hit. So watch out for people if you do decide. And whatever you do, don't hammer into cliffs. That's the last thing I want you to do. If you do go on the beach, only ever really take stuff which has come on the beach, which is already away from cliffs. Cliffs are a tricky thing, and I would argue that, you know, you should really stay away, especially steep-sided vertical cliffs, you know, because they can be unstable, especially after very wet weather or very dry weather. And you get rock fall. If you look down the coast, you'll see rock fall, and they're not particularly safe in a lot of places. You will see warning signs for these. So this is my safety on the beach sort of slide. Look out for signs because they're there for your safety. And obviously, you guys, or I suspect I know Stan, you live near the sea, but you're probably a bit more close to the sea than I am. I'm in the East Midlands, so I seem to be a very long way away from the sea. It's at least 2 hours away from me. I probably don't need to tell you about tides and steep beaches, and as I said, hammering into cliffs, and eye protection. So let's come on to this thing I was talking about earlier about legality. Now, you may or may not have seen articles saying it is illegal to take pebbles from the beach. Well, they all refer to this, the 1949 Coastal Protection Act. And that gives coastal protection authorities the power to create a bylaw to prohibit the excavation of material. Okay, now this is the important thing. It gives them it's essentially the option to create a bylaw. There is no blanket banning of automatic banning of material collected from beaches or coastlines in the UK. Coastal authorities have to apply to a minister. That minister has to then approve that. And that is the case, so that you will find certain beaches in the UK have this bylaw in place. If that is the case, there will be signs, because they don't want you to take stuff, so they've got to tell you. If there aren't any signs, there's probably no bylaw. I say probably because I can't say for 100% sure, because I can't find a definitive list anywhere telling me which beaches or stretches of coast in the UK have the bylaw in effect in this sense. And there are certain famous places, Budleigh Salterton, Chesil Beach, Clackington Haven, where unfortunately for somebody, he must have taken a large number of pebbles, I think. He must have taken carrier bags full, and he had to come back to return. He was forced to come back to return the pebbles to the beach, which is unfortunate, but there are signs on that beach. He just ignored them. And these are the sorts of signs. Like I say, I don't know the numbers. This is the sort of thing you're looking out for. They're going to be obvious. Some of them look a bit homemade, but that bright yellow one on the left there, it's pretty clear, really. I think actually the locals complained about that sign because it was too bright. So they had to replace it with a less bright sign because they say it wasn't particularly very attractive. So it was replaced. And it's not a particularly welcoming thing to see when you go, but there's a good reason for this, and this is largely for coastal protection. This is to try and stop coastal erosion ultimately. And certain places like Budleigh Salterton, where you get really lovely round pebbles, people think, oh, these would be nice in the garden. And that's why there's a concern. And the same with Chesil. It's a problem. And yes, if you've only got a thin cover of pebbles, you are going to accelerate coastal erosion. The cliffs are going to get undermined. And there's certain places where I've even seen, where was it? In Norfolk, where I saw a gentleman physically stacking the pebbles against the cliff as it has his retirement hobby, because he was trying to protect the cliffs from erosion. And it's got off my head now. It'll come back to me randomly where the place is, but I thought this was very interesting. But he'd done a lot of work, and there were huge piles of pebbles. The thing was, he basically color coded them, so there was a white pile and a red pile, and along the beach. So good for him, I say. It kept him fit as well. Here we go. Here's a few of my recommendations for books. Now, these are, the one on the left is The Pebbles on the Beach. This is the famous one. This was written in 1953 by Clarence Ellis. I've got a copy of this book. And it's republished in 2018 with a foreword by Robert Macfarlane, who you may have come across. He's an excellent writer. It's actually worth looking at for his books as well. But this is, if you're interested in specific locations, about the process, the more details about how pebbles are formed, this is excellent. Bear in mind, it was written in 1953, so it's actually quite a little bit old-fashioned, archaic in its style, but it's still a very excellent reference. He covers England and Wales. He didn't quite get to Scotland. I'm not sure why. He did get to Northern Ireland. So if it's England and Wales only, but it's still very good. And he works his way around the coast, basically. Really interesting. The one on the right is a more recent book. It was only published in the last couple of years. And the Book of Pebbles, it's a bit more of a romantic take on pebbles. I bought a copy of this book, and one lunchtime, I just sat down to read it. I read the whole thing in one go. It took me about an hour and a half, something like that, to read it. It was very light, very nice, and it was a pleasure. It's a bit more of an artistic take on pebbles, and that was a very nice book. I enjoyed that. I've sent a copy of my presentation to you, Stan. So if people want it, I can. Basically, I sent it as an email, Stan. If you look in your email, you'll find it. So if people want it, they can. I'm happy for them to have it. There's another couple of books here which are a bit more technical. The one on the left is the classic Dorling Kindersley style, excellent photographs, excellent range of rocks and minerals. I use this one all the time. In fact, I've got a couple of versions. There's a big hardback version of this book, and there's a smaller paperback, sort of more concise version. This is one of the best books that I found for just variety. The one on the right is better for classification, a bit more going into the different types of igneous, sedimentary, metamorphic rocks. Again, this is excellent. I've used both of these when I was writing my book. I recommend them to people. These are excellent if you're a student, or if you're more keenly interested in geology. There are obviously lots of other books out there. If I go into a bookshop, an independent bookshop, I'll always look in the geology section. In Sidmouth, I did the same thing. I came across another mineral book that I'd never heard of before, so I bought it. So it seems, and it had been around for a few years, so there's a lot of books out there. Just look through them. Do they have good clear images? What often happens with books like this is that you'll find they show you impossible specimens. What you'll see is a museum type grade quality specimen, which you'll never find on the beach. It's a sort of once in a lifetime type thing that you'll often find in the Natural History Museum or something. And that's not really much use to somebody who's actually maybe trying to strike out and learn about geology. I mentioned there were apps. If you've got a smartphone, frustratingly, this is not on Android anymore. I'm not sure why. I think they're updating the app, so I've got a feeling it's going to become more of a web app. This is really useful if you've got an iPhone. Basically, this has all of the British Geological Survey maps. And the beautiful thing about it is that you can take the map wherever you are. You can click a button and it uses the GPS on your phone to locate you wherever you are in the UK. And you can see here, I've picked a couple of places in Devon because I thought, well, I've got to make it more relevant. And if you click on the geology, you'll get this information above. And there's an option then to learn more. And this is drawing on the geological information from the British Geological Survey. We have something called the lexicon, which is essentially the Bible for geology in the UK. This gives you the information about all geology, all rocks, all formations, all different types of geology. It's an excellent starting point. This is the app that you can actually create an account with. And I mentioned you can upload photos to. So if you upload a photo, if you have a photo of a particular location and you pick a point on the map, it will then actually correct you and say, did you mean 300 meters to the west? Because it uses the GPS information on the photo to accurately geolocate the image. So there's actually a photos feed in this app. It's really, really handy. And it's good for us as geologists because for BGS geologists, we don't get to go everywhere, or we can't afford to go everywhere. So it's nice for us to see this, and we might see geology, or people have uploaded images from across the UK, which will help us in our work, which is really, really nice. If you haven't got a smartphone or you haven't got an iPhone, the alternative is to use something called the Geology of Britain Viewer. This is online on the internet. And there's the link there. But if you Google Geology of Britain Viewer, you will find this. And this is basically the same as iGeology. It's the geology of the UK. You can zoom into the geology and you can query it the same way that we did with the app. So here we go. Here's Ilfracombe. So I've done the same thing. I've zoomed into the geology and I've clicked on the geology and I've got the description of the geology. So you can use this. And there's a slider top right. You can slide the transparency of the geology so you can see where you are. If you slide it all the way across so it's opaque, you'll only see the geology. You sometimes need to work out where am I in the UK, so you slide it across to make it more transparent. So I put it halfway so you can still see the location behind. That's really useful. I use this regularly when people send me images of a rock on a beach somewhere. I'll often just use this to say, well, where was the beach? And more or less every time, the geology on here will match the rock type that they're showing me. This is my way of confirming that I've identified the rock properly. So for example, here we've got slates. So you might have limestones or sandstones or whatever else, different types of rocks. So it's really, really handy. That's the sort of slidey bit. What I'm going to do now, I'm just going to show you a few rocks, as you would expect. And there's about half a dozen, I think, here. And I'm just going to sort of talk about these particular rocks. And this is the one I showed you earlier. This is a volcanic rock called Rum Porphyry. And this is a nice one. As I mentioned before, when I went to Cromer with Paula Kokoza from The Guardian, this is what we were looking for. And we scoured the beach for ages looking for this. And she had to get the train. So she disappeared and got the train to go back to London. I said, well, I'll hang around for half an hour and look. And literally within 10 minutes of Paula going, I found it. And I think I basically found this. And it's a Rum Porphyry, it's called. Basically, if you look, you can see the big crystals of feldspar that you can see have a sort of diamond shape. Sometimes they're a little bit indistinct, but some types you can see are very clearly diamond shaped. And this is unique. Basically, this is a volcanic rock. And what's happened is that before the magma has been erupted, these crystals of feldspar have grown within the magma. So when the magma has been erupted, you get this sort of this style of volcanic rock. And there are only 3 places in the world that you get this rock. The only place in Europe is just outside Oslo in Norway. What was this doing in Chroma? Out of place, basically. What is it doing there? It's essentially been brought there by glaciers, which have traveled the North Sea and deposited their load when the glaciers have melted onto the beach. If you look at the beach in that part of the world and going up the East Coast, you get a lot of glacial material. The glaciers have essentially scoured the UK, and as they've gone along, they've frozen onto lumps of rock and they've plucked them out and they've deposited them. So you find all sorts of rocks from Northern England, Scotland, across the East Coast. Fantastic location, Yorkshire, Lincolnshire, Norfolk, for finding pebbles. Fantastic. Aha, the next one. This is this one. This is a limestone, and the little circles that you can see are corals. And this is a carboniferous limestone. It's really nice. It's a sort of thing that I found. I can't remember where I found this one now. I think, again, this was in Yorkshire. It's in the book. It's a really nice piece. If you're looking for fossils, or if you find fossils in the rock, it's very likely that rock is limestone. Limestone is made of life, basically. It's made from the remains of shells, and they've been crushed up, and occasionally you get them preserved. Sometimes you get fossils in the mudstones. You know, say if you go to Charmouth, Lyme Regis area, you get mudstones like the Lias. Sometimes you get them in sandstones. Not very well preserved in sandstones because it's much coarser. But there you go. There's that one. Ah, here we go. This is nice, quite literally nice. This is nice with a G. It's a silent G, and this is a metamorphic rock. This came from Scotland, and this is very old. As a rule of thumb in the UK, the further north and west you get, the older the geology. So that if you go to northwest Scotland, you get something called the Lewisian gneiss, and we're looking at rocks which are over 1 billion years old, so hugely old. And this started life. This particular one started life probably as a sandstone, I think. And you get others. You get granites which are changed into gneiss as well, and they're largely made of things like quartz and feldspar. But you can see the swirling pattern of that layer there, and that's telling you of the pressures that this rock has gone under to buckle and fold that layer of rock. So immense pressures. Ah, another one. I seem to have picked all the spotty ones. So this one, it's not a coral limestone. This is another volcanic rock. This is a basalt. And what you're seeing, those little dots of crystals, what happened when the magma was erupted as a lava? Magma tends to have lots of gas in it. And normally when the lava is runny, that gas bubbles out and escapes. Sometimes when the lava's cooled down, those bubbles of gas get stuck in the lava. It becomes too viscous for the bubble to escape, and you get a little hole. That hole is called a vesicle. That hole then gets infilled with other minerals, little white minerals, and that then becomes an amygdale. So this is amygdaloidal basalt. A bit of a mouthful, but that's really nice. That's a really good one. That was another one from Yorkshire, I think. Ah. Hopefully you should be able to tell me. You should be able to tell me what this one is. What it actually says up there. That's the giveaway. But with a sandstone, you can usually feel. Often you can't feel because it's been cemented. Sometimes with some sandstones, they're so very cemented together, they just feel smooth, but they are sandstones. And with this one, you can see the layers, the sedimentary layers within the sandstone. And it's what it's. Yeah, it's a rock made of sand, basically. Ah. Excellent. This is one of my favorites. Can you see that sort of wavy surface to the rock? And this is called a phyllite. This came from Scotland. This is a metamorphic rock that started life as a mudstone. And what's happened is, due to metamorphism, the rock is basically, you get this cleavage on the surface, and you also get the little dots. And because of the temperature and the change of the pressure that the rock is under, new minerals start growing in the rock. So these are called porphyroblasts in a metamorphic rock. So this is a lovely rock. I was quite taken with this one when I found it. Ah, there we go. The next one is another lava. It's another porphyry. And can you see you've got the white feldspar crystals, but also if you look very carefully, there's a little round grayish crystals of quartz, relatively clear. This is actually called a quartz porphyry. It's another volcanic rock similar to the Ron porphyry. These crystals have grown in the magma, and I found this on Arran in Scotland. And I wasn't looking for it. I found it. It found me, which is a really, really amazing addition to my collection. That's also in the book. Oh, this is not, this one doesn't belong to me. One of my friends lent me this many moons ago. She hasn't had it back yet. This is a flint pebble. And you can see the flint here. Flint generally has a dark interior and a sort of whitish surface, like a crust. But sometimes the flint preserves fossils. This is an echinoid, and basically this would have preserved sea urchin. Basically, this would have had spines. And what happens? The theory goes that the silica from the living creature has been preserved as flint. That's why you get a lot of flint in the chalk. It's organic, basically, and that's basically when the rock is formed, that silica then migrates and then forms flint nodules, or very occasionally it might replace the shell of an animal. This is a pretty nice one. You will have to look at a lot of flint pebbles. I've never found one myself. There are probably billions of flint pebbles in the UK. And if you looked at enough, you'll probably find them. Right? I've seen them on Twitter and Facebook and stuff. You'll find that. That's a lovely fossil. Ah, the next one. Can you see that the shiny surface of this one? This is another metamorphic rock. This is a rock that also started life as a mudstone. So if we took our phyllite and kept applying pressure, ultimately we'll recrystallize the clay minerals into here into mica, and that's what you see on the surface here. And generally what happened is the mica lines up, it's layered, sort of like aligns essentially. So this is called a mica schist, S-C-H-I-S-T. So that's another metamorphic rock. That's another Scottish rock. Ah, well, I don't have this one out. This is a gabbro. This is a rock that has formed from magma, but it stayed deep underground. And compositionally, it's very different from granite. And you get these feldspar and hornblende and other minerals, dark minerals, forming in this rock. This is a gabbro is a sort of rock that forms deep under the UK and also under the crust, under the oceanic crust. So you do get it in various places. You do find it on land in certain places. For example, this thing's called ophiolites, which are basically slices of ocean crust which have been by tectonics have been shoved onto land. And in various parts of the world, you'll find this. And also you find gabbro up in Skye and places like that, where the erosion has revealed the roots of the continents, basically. Ah, this is a piece of chalk. Again, this is a type of limestone. This is formed by microfossils called coccoliths, and they're really tiny. You have to use a microscope or even a scanning electron microscope to see the fossils. It's completely made of fossils. It's a pure limestone. It is used in industrial processes because it's very pure, but obviously we're talking chalk cliffs of Dover and all those sorts of places in the UK. And a granite. Oh, here we go. Here's the granite. And this is a classic. This is a rock, an igneous rock, similar to gabbro in the sense that it's a magma that's crystallized deep underground. And you can see sort of glassy looking quartz. You can see whitish looking feldspar and pinkish looking feldspar, two different types of feldspar, and little black flecks of probably biotite mica. So that's the sort of classic composition of a granite. And the nice thing about rocks like this is that you can actually see the crystals writ large. It's not a fine-grained rock. You will obviously get them bigger than this. Certain places down in Cornwall, you might see very large crystals of feldspar. And these are called phenocrysts. And in other places in the UK, like Shap, for example, you get lovely big phenocrysts, these lovely sort of rectangular crystals of feldspar. And there you go, folks. That's the sort of end of the Pebble display. Just a few last things. I spend a lot of my time now, it seems, looking at pebbles online. There's not 218 members of this group now. It's my Facebook group. the pebble spotting group if you're interested. It's more like 250 members. Every time I do a talk, a few more people join. If you're interested, join the group. It's a good way. If you can share the images, the photos of pebbles that you found, you're more than welcome. I'm on there most days trying to identify images that people have of photos of rocks. So you can post your images. I tend to use a hashtag called Pebble Spotters, so Twitter, Facebook, Instagram, etc. And thank you very much for your attention, everyone.